For the last video for this lecture, it'll be kind of short because we're just going to breeze through the other antibiotics. My main goal with Lecture 8 Part 2 was to get you to think about antibiotics in a different way. And so if you go through the whole story of the beta-lactams and vancomycin, that gives you a complete picture of a type of antibiotic, how it works, how resistance to it could work, how we respond to resistance to it, how resistance builds up in the future, and how we have to think about it. And to me, that's much more important than you memorizing a bunch of antibiotics. So here we are at the antibiotics that do not disrupt the cell wall. And what I want you to do as you go through these is to memorize the names and what they do, so their mode of action, and that's it. Everything else here is interesting, useful to know, but what you need to know is the name and what it does. So the first one, Tetracycline Doxycycline, these are common. Tetracycline is the group. It's named after this 4-cycle shape, tetracycline. And they are great because they can get into cells and go after the rickettsia, etc. They're toxic in some cases, but they're also some of the only ones we can use in some cases. So for that, we really value doxycycline and the other members of that group. Oh, and they're translation inhibitors. That's the thing you have to memorize. Tigecycline is a new tetracycline, and it's interesting because somehow it increases certain risks for patients. So it's interesting in that way, but it's useful against MRSA and VRE, so vancomycin-resistant enterococci. And it's a translation inhibitor just like the other tetracyclines. Polymyxins are a different group. Colistin and polymyxin B are both complex shape antibiotics, and what they do is they disrupt cell membranes. And if you were going to prescribe these, you would need to know that they are toxic, very toxic, to different parts of the body, and they can't be given orally, so you need to manage this toxicity and be aware that you have to keep track of kidney function and look for any signs of neurotoxicity. Daptomycin is a newer antibiotic, and it's bizarre. It breaks down the proton gradient. And we've always had drugs that disrupt the proton gradient, but we've never had one that does it to bacteria without doing it to mitochondria also. So there are some of the most toxic molecules we have are molecules that break down the proton gradient in mitochondria because they kill all of our cells. But daptomycin doesn't do that. It targets gram-positive bacteria. And so it is useful as a backup against MRSA and vancomycin-resistant enterococci. Chloramphenicol is a great antibiotic, but it causes irreversible bone loss in some people, and it has other toxic effects. So we don't use chloramphenicol much in the US, but it does have a very broad spectrum, and it's very cheap. Apparently it's like pennies per dose, and so it's used all over the world, often over the counter. This is the newest one, and it's another translation inhibitor. I don't know much more about it, other than it's expensive. Clindamycin, this one's famous because it was used a lot against pathogens of the gut, and it's a fairly broad spectrum, and it was the main factor in C. diff infections and severe cases of Clostridioides difficile or Clostridium difficile. And so using clindamycin was, well, people aren't going to use it willy-nilly anymore, just because of that. The macrolides, like erythromycin, these have this weird giant structure. I don't remember much else about them or when they're used. Aminoglycosides are a big group, and aminoglycosides, glycosides is going to mean they kind of look like sugar molecules, or they are sugar molecules bonded together in weird ways with amine groups coming off of them. And a lot of these come from the Streptomyces bacteria, and some of these are great against gram-negative bacteria. That's all I remember about that. And then the last ones would be the fluoroquinolones like ciprofloxacin, which inhibit DNA synthesis. And these can get into cells and work against pathogens inside cells. So these are exciting, like the tetracyclines. And I don't have much more to tell you about these. So anyway, that's it. Good job hanging in there for all of Lecture 8. It's huge. Again, the first set of slides in any unit is going to be huge. And this is this one. But I hope after you have gone through all this and studied it, you will think about antibiotics in a slightly different way. And you'll be ready to learn more about antibiotics, and you'll be looking for different types of information when you hear about antibiotics. So hang in there, study, 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 and I will see you when I see you.